Hello, it's late in the day, so I'll try and be very quick with this. So I'm from UNESCO, and the Intergovernmental Oceanographic Commission, or IOC, is the UN agency for coordinating ocean science around the world, and we've put together a use case in partnership with Terra Due, and I'll explain that right now. So why have we put together this use case? The IOC's mandate is to promote international cooperation for ocean science. And one of our lead programs is the Global Ocean Observing System. It's the global program where it facilitates the collection, storage and use of ocean data to support society. So we use the science, but we always bring it back to social benefit. To store ocean data, and we're taking new data all the time, but there's also data that's been around for 50 to 100 years, depending on the scientific method. We use that and we transform it into ocean products. And the ocean products are what are useful for social benefit. And to get from the raw data to the ocean product, we need to go through a modelling process, analysis, and to create those indicators. And to do that, it requires large computing facilities, and that's where we bring in the cloud. So cloud computing could then become a viable way of handling large amounts of ocean data, and without the need for the sophisticated local computing facilities, which scientists often don't have. You get large countries that may have it, but university institutions don't have it, where the scientists are often working. And you also get the developing countries who many of them are coastal nations, and they just don't have the computing facilities to process the data that's provided to them from the developed world. So an example of an ocean product, or a theme of ocean products, is called ocean forecasting. And ocean forecasting, similar to weather, you're using the ocean data that you're accessing to model and provide forecasts of future ocean conditions. So what's the weather like almost in the ocean, under the water, what's happening down there, the current movements and everything like that. So the benefits for society, there's a variety of end users, and that can include commercial mariners, sailors, fisheries managers, and I'll just give you some examples of ocean products that we've got from ocean forecasting. And I know I'm in a European context here. I am Australian, and I use Australian examples just because they're the ones I have. It's not to say that they don't exist in Europe. So applications to industry, we've got oil and gas industry here. The actual engineering design of oil and gas infrastructure to put pylons into the ocean and to put it on the ocean bed, you need to understand the undersea currents and the undersea waves that are going on, and it's very important because they can be very different at the subsurface than at the surface. So you can see on down on this side, it's an example of modelling using ocean data. The red spots are very strong areas of current, and you can see the circulation of current by the direction of the arrows on that. Related to that, that's just in the application of building oil and gas platforms, in the management of oil and gas operations, in the unfortunate event of oil spills. And here's an example of a fire that occurred on an oil and gas platform off Australia. It resulted in a massive oil spill near coral reefs, and ocean forecasting was used to try and figure out in which direction that oil spill would go, and then an emergency response can be put in place to try and alleviate that. Another example, ocean renewable energy. If you can determine where the stronger currents are, and also the thermal differences in the ocean circulation, you can then identify areas where you can build facilities for ocean renewable energy. And that's pretty important in this current time when we're looking for renewable resolution. And another one, fisheries. And here we've got examples of southern bluefin tuna management, where the tuna are tagged, and the information, we extract the information, and there's also the actual ocean monitoring information coming from the ocean currents, from buoys floating around. We combine that with the habitat preferences for the southern fin tuna. Then we can start to model the preferred habitats for the southern ocean tuna, the particular temperatures that they're in, which way the currents are going, which way they might move, where they're spawning. And if you can determine the habitat prediction, then you can also make a better management decision. This is critically important for the developing world, where so many of those developing countries who are coastal nations rely on fisheries for their gross domestic product, and they don't have the capacity to model this. And this is where Europe can be very involved in providing that information in an aid context. So that's examples of ocean forecasting products, but basically to get to the product, we start with either satellite information of the ocean or the actual in situ data from the monitoring buoys that are floating around, or measurements that are taken from ships. So you get the real-time observations. You need to go through then a processing. It goes through a quality control. There's data assimilation, model simulation, and data management. And the central image there is a national computing facility, and you can see it's a very large room with several large computing facilities required. And this is the aim, to reduce the actual facilities required and reduce the time it takes to process to get these ocean models and products and services. So as you've just seen, it requires large stacks of multi-temporal data. You process it in the algorithms and produce the models. We need those high-performance computing facilities, and we also need to know that the facilities are interoperable, and we need full and open access to the data. And under the Global Ocean Observing System, that it's promoted that it's full open access, and also under GEOS, which the Easter presentation beforehand, the flagship presentation, described that GEOS, the Global Earth Observation System of Systems, has a data sharing principle that we will be able to openly access the data from Earth observations. So in a nutshell, there's an enormous potential for cloud computing to assist and improve the efficiency of this process, and especially it will mean more quickly we can create ocean products. We can deploy those models, especially when we're responding to emergency situations, for example in an oil spill, and we can develop local capacities, and then for that one in particular I refer to the developing countries. At the moment, ocean forecasting is, I guess, managed by a group called G'day Ocean View. They're an international body, and they're a consortium of government agencies around the world who produce the models for ocean forecasting. So an individual country might be gathering ocean data and producing the models, but the oceans are international territories, so you've got a consortium of governments working together, and I think that's really critical when it comes to cloud computing. You know, Europe is not just taking ocean research around your immediate borders. There's research going on in the Indian Ocean, in the Pacific Ocean by Europeans, in collaboration with the Americans, the Australians, the Japanese. So there's this real consortium to cooperate and get the data. So there is a challenge. The Helix Nebula is clearly focused on Europe, but the challenge is also, if we've got this enormous potential for cloud computing, the G'day Ocean Forecasting group said, well, we're really interested, but we also need to know how it's going to work when we are this large international body. So that's a challenge, food for thought, and I don't think it's insurmountable. It's just something to think about at the moment. So from that context, which I wanted to provide you, this is where we come to the candidate use case, and we've called it the Ocean and Coastal Information Supersite. And our role as ISC UNESCO is a conveyor. We don't do the research. As I said, our mandate is to promote international cooperation of ocean research. So in that role, we would convey the idea of the Helix Nebula and the promotion and encouragement of Helix Nebula and cloud computing. And we know our customer needs, we know our clients, our ocean scientists around the world, we know what they need, we know how to bring them together, and we can start to promote Helix Nebula to them in that way. Our partners, as I mentioned, Terra Due are providing infrastructure integration support, but in terms of the actual ocean science component, G'day have said that they're interested to learn more, and we've also got JCOM, which is a marine meteorology group where the ISC combines with the World Meteorological Organisation to conduct ocean research and produce ocean products. So there's an interest there as well. We have other SMEs that are also interested, and the data centres, particularly for Europe, there's the Ocean Research Data Centre Coriolis, which is heavily linked into ESRIN in France, but their subarm, which is called Mercator, are producing ocean products, ocean forecasting products. So I think there's a real strong synergy there that can be used with the Helix Nebula. So the approach is what we would do is start with these national centres in the G'day Ocean View, for example, Mercator Coriolis, seek the use of cloud compute. They are seeking the use of cloud computing under the Helix Nebula, and then through sharing the data set types, the different ocean data that is coming through, we can pull that information together to create the ocean products in a very efficient way. It's only possible because we coordinate. I guess the critical thing from my point of view under the IOC is you need coordination and collaboration to share and have open access to the data, but to know that you're working in an intergovernmental setting. The final customers of the Helix Nebula won't be the IOC UNESCO. We're promoting it to those countries who will use it. And the expected benefits, obviously, is to create ocean products much more quickly, more efficiently, and that has a spin-off effect, obviously, economically. It improves the, I guess, the research money side that you can be putting into other ocean products to create. And obviously, the storage and ingestion operations are more efficient. And you also get increased numbers of users to the system. And again, for developing countries, for example, if I was in Thailand, as a researcher in Thailand, and I wanted to know what was going on in the seas near there, I could access the Helix Nebula with the information that perhaps Mercator and the European group have put into that, and then start to work out what you're doing, for example, with fisheries. So that's the idea. Currently at the moment, I'm personally on a project called GeoWow, which is the GEOS interoperability for weather, oceans and water. And that's it's part of the group of Earth observations idea that we want to improve the GEOS in the next few years. The EU FP7 are the major funder of it, and I'm involved in what's called the oceans component of that. So we're trying to improve the oceans data set in the GEOS. And at the moment, we're working with our partner Terra2 to develop the infrastructure to support the creation of an ocean indicator specifically focused on coral reefs around the world, and which coral reefs in the next 30 to 50 years will be vulnerable to sea level change, rapid sea level change. So this is an example of building an indicator, an ocean indicator, using multiple data sets, and we're using the cloud to do that. And I think this is our test case. We're testing it and we're seeing how it goes. And from that, with GeoWow, we've got funding through this project to then consider how we would also put that into the Helix Nebula rather than approaching someone like Amazon. So just to wrap it up, the success obviously is going to improve the efficiency. We will end up with more better ocean forecasting models, which is critical to society. And finally, it assists capacity development. And I always bring it back to the developing countries, because as part of the UN, that is our mandate as well. We're promoting sustainable development around the world, and Europe, as well as other developed countries in the world, have an aid program and put that towards it. And I think it's important to realise how much of the European ocean data is put into the developing countries and used by them. Anyway, so that's it for me, and if there's any questions, I'm happy to answer them.
Thanks, Marilyn. So, data access, this data is freely available in a research component?
Mostly.
So
yes.
if I had, say, I can't even think of something, a tide pool census data, I could take your tidal data and compare it to my tide pool census data?
Yes, you should be able to.
Without significant cost?
Yep.
So this is really about building an ecosystem of participants.
Yes.
And then hopefully, as you say, finding social benefit from it.
Yes. So under the Global Ocean Observing System, already it's a similar philosophy that the countries around the world, they'll do their own research in the country, but they'll put it together under the Ocean Observing System to pool it so people can access the data freely. And the cloud computing will be a tool in the way it will improve that, because people will be able to access it far more easily than they have been able to. Yeah. And I think also it'll make it a much quicker process. Yeah.
questions?
Thanks. My name is Espen Volden. I'm with the Secretariat of the Group on Earth Observations, GEO, based in Geneva. GEO has already been mentioned here. First, thanks to Sveinung Løkken, who introduced it in the ESA flagship presentation, and you also mentioned it here. So it's a global organization working to build a global Earth observation system of systems with 90 member states now and 67 participating organizations. So it works with trying to link Earth observations together and to promote data sharing, trying to coordinate and boost development of information products and services, as has been mentioned here, also was shown, for example, for the geohazards supersites. Geohazard supersite is part of what we call the disaster societal benefits area of GEO. And we have 8 other such societal benefits areas, and we have some cross areas tasks. Like we have one which is about coastal and ocean areas called Blue Planet. In addition to this, I just wanted to add this is we are working on a common infrastructure for GEO about how to provide discoverability of the data that can be shared to make them accessible, and we've made progress of this, and also we're working more on making helper applications easily available, so that you can manipulate and process the data without being able to download them. So that's where I think also where both cloud computing and private sector is coming in. We're trying to boost the involvement of the private sector in GEO now, and just change our rules to make this easier. What I just wanted to pass as a message here is that okay, I'm very glad to see that the GEO is used in a way in several of the use cases here. That's my message, that you should try to take benefit of the coordination frameworks, the networks that exist in GEO, through the GEO work plan, through the task teams, through the communities of practice, which also bring in the practitioners to how to help them use Earth observations. So for Earth observation related activities like this one, and I think there will be probably in the next one that will see weather also, and for new cases, really take benefit of this. That's my message. Thank you.
Thank you.
Do you have standards for the data formats? Because this is linked to the previous questions. Because, for example, astronomers, after many decades of working together, they actually can take radio astronomy data and infrared and visible, and actually, with a standard tool, superimpose them and so on.
Yeah.
Do you have such things?
You do, and it depends on the actual ocean data that you're looking at, but yes, there are standards.
Congratulations.
Yeah.
But to be clear, those standards aren't yet universally adopted?
Not necessarily. I mean, there's a push to do it, and that's part of the Global Ocean Observing System. But it totally depends on the country and the resources that they have to get it up to the standard. Yep.
Now, without making a long speech, one of the things that we hope to introduce, I'm from Cloud Signal, by the way, one thing we hope to introduce into the Helix Nebula concept is this idea of metadata. This idea that as these disparate databases become available, a guy might have some World Health Organization data that he wants to marry to coastal erosion data. And he's going to need to have a common, is it latitude, longitude, is it 1 square mile per frame? We're going to have some interesting discussions about data normalization.
That's a fair comment, and the work we're doing in GeoWow and that coral reef indicator I mentioned, we're looking at socio-economic data to marry it into it, and so that's when it opens up that can of worms to look at it. Yeah, it is.
Any other question? Yes?
Thanks. Now, I just had one question related to assisting capacity development for developing countries. If you could you just explain a bit more concretely how you help the developing countries with this and how cloud computing can really be efficient for this?
Well, it hasn't been done yet, but what we envisage is a lot of the developing countries, for example, in the South Pacific, the small Pacific Island countries there just do not have computing facilities to produce products on perhaps where their fish are migrating or things like that. But you might have, for example, Australia or Japan or America, the neighbouring Pacific Rim countries, who can produce that for them, but then the product that they can access, they still can't use it on their computing system in those countries. So if there's some link into, say, the cloud, where they can access it through the cloud and get the results through the cloud, it saves them needing that computing infrastructure. And I think that's critical to giving them that information that they need, but often they just don't have the logistics to use it.